Okay, so I am Harmeet Singh Lubana. So we are going to study geography. Within geography, we are going to study atmosphere. Like there are two components in atmosphere. We are going to study composition and structure. These both things in the atmosphere are relevant for prelims and mains of UPSC and MPPSC. Within composition, like within composition, we are going to study that what are the composition within the atmosphere. But prior to that, we have to understand what is atmosphere. So atmosphere is nothing, it is a blanket of gases surrounding the earth. Like there are gases, and this is the earth, these are the gases surrounding the earth, and these gases are forming an envelope of gases surrounding the earth, and this is known as atmosphere. Okay, this is the minor definition of the atmosphere. If there is a question in mains that what is the composition of atmosphere, we can start in our introduction with the definition of atmosphere. Okay, so let us talk about the composition. So there are multiple things in the atmosphere. The first thing is gases. They are different gases, but let us first analyze what are the things. Second is water vapor. Second is water vapor. Third is aerosol. And the fourth component is dust particles. Okay, so this is the composition of the atmosphere. We have to study that what are the gases, because this is most important for prelims and mains, because they are going to ask that what are the gases in the atmosphere. They can ask composition of the atmosphere, what are the gases to arrange in chronological order, that what are the gases in atmosphere, arrange in chronological order, or in prelims they can ask that which gas is in abundance in the atmosphere. So the composition we can understand through a chart. Like this is nitrogen, which is 78%. Okay, so within a gases section, atmosphere contains 78% nitrogen. In this section, we have 21% oxygen. This is oxygen, which is 21%. These are the other gases. Within other gases, there are multiple things. Okay, should I rub? So within other, we have first organ, second CO2, carbon dioxide. This is 0.8%, and this is 0.03%. Okay, and the third final is other gases. It involve krypton, radon, xenon, and all other gases. All gases are come in other, which its composition is less than 0.01%. So we are not going to invest our time in this, but we have to remember that first is NO2, the second is CO2, and then these two gases. Okay, they can ask question like that, arrange the gases in chronological order. So we can arrange that first is nitrogen, second is oxygen, third is argon, and fourth is carbon dioxide. Okay, they can ask the question like which gas is in abundance, so we can know that nitrogen is abundance. So this is the composition of the atmosphere. Let us talk about the structure of atmosphere now, because for structure also there are certain questions, but most probably the question will be in mains regarding the structure of the atmosphere. Okay, so let us talk about the structure. So probably the question from the structure is that, the first question is that they simply ask you that what is the structure of atmosphere. What is the structure of atmosphere? Okay, So you have to write start from what is atmosphere, that we have discussed, that the envelope of gases surrounding the earth is known as atmosphere. Then start with structure. First of all, let us understand through a diagram. Let us consider this is the earth's surface. Okay, these are the things, these are the temperature range. Okay, this is the height. Okay, this is the height, this is the temperature range. The first layer, second layer, this is troposphere. This is the troposphere. Second layer is stratosphere. Third layer is mesosphere. This is the third layer. The fourth layer is thermosphere. This layer is also known as ionosphere. And the outer, above it, the fifth layer is exosphere. This is the layers. Okay, if we arrange this in uh, height, or we can define the range, then this is the earth's surface, which is 0 kilometer, 0 to 13 kilometer on an average. The spread of troposphere is in this range, 0 to 13 kilometer. Above it, 0 to 50 kilometer, we have stratosphere, the range of stratosphere. Above 50 we have 85 kilometer of the range of mesosphere. Above it there is 600 kilometer, the range of thermosphere, which is also known as ionosphere. And exosphere have a range of 10,000 kilometer. Okay, so these are the ranges. This is the broad thing regarding the structure of atmosphere. Let us come to troposphere first. Here we have to explain what is troposphere. There are certain things or frameworks within which we have to study about the troposphere. First is the range. Everything is studied in this framework, like what is the range. Second is what is the composition, that what are the things are present in particular layer. Okay, range, composition, and the third thing is relevance. What is the relevance of particular layer? Okay, we are going to study this all layers within this framework, and I hope that you write answers in this framework only, so you it will be easy for you to remember the things. So let us talk about first of all troposphere. Okay, so let us talk about troposphere. First of all, the range. We know that range is 0 to 13 kilometer. However, this is not true for everywhere. For example, there are two components on the earth. One is equator and other is poles. For equator, the range of troposphere is 0 to 18 kilometer, and for poles its range from 0 to 8 kilometer. Now why this difference in the ranges at equator and poles of troposphere? Okay, this is range we are studying. So why there is a difference in the ranges? There are certain reasons. So what are those reasons? The first reason is that convective currents. We know that when sun rays are strike on the earth, sun rays are slanting and poles, but they are directly striking at the equator. For example, this is the earth, this is the equator, this is the poles, this is the sun. Sun rays are directly at the equator, therefore equator get more heated. Since there is more heat, therefore there is intense low pressure condition has been formed at the equator region. Since there is intense low pressure condition, what will happen? The convective currents, these convective currents will form. These convective currents, which is more intense at equator, achieve more height as compared to this pole region. Since pole region have slanting rays of suns. For example, in this way, poles are receiving sun rays, which is known as insolation heating. So pole have slanting rays. Therefore, the low pressure condition at the poles is less. Since the low pressure condition is less at the poles, the convective currents will not achieve greater heights. Since convective currents are not achieving greater heights, therefore the range of troposphere is higher at equator, and the range of troposphere is low at the poles. So this is the reason behind this range differentiation in troposphere. Okay, so one thing we had completed, which is range. Okay, let us talk about the second thing. Second thing is, we know we have completed range. Second thing is composition. Okay, so let us talk about the composition of. So let us talk about the composition of troposphere. So we know that troposphere is lowermost range of atmosphere in the earth's surface. Therefore it contains gases. All the atmospheric gases are concentrated in this layer. Second is water vapor. All the water vapor is available in this range only. Okay, gases, water vapor, dust, particles. Okay, so the composition of troposphere is this: it contains gases, it contains water vapor, and it contains dust particles. Okay, now what are the gases? We already studied in the composition of atmosphere that what are the gases and what is the percentage of those gases is available in the atmosphere. That composition is true for troposphere also. Water vapor, the data is 4% on an average. On an average, earth atmosphere contain 4% water vapor according to 11th class NCRT. Okay, you don't have to write this, but I am just telling you that there is 4% of water vapor present in the earth atmosphere according to NCRT. These are the dust particles. Dust particles are also abundant in troposphere. Okay, so this is the composition of troposphere. Let us talk about what is the next thing is there. We have to know, we know about range, we know about composition. Let us talk about relevance and temperature. Okay, so let us talk about the relevance. First of all, we have to know about what is the temperature range in these atmospheric layers. In troposphere, the temperature, let us divide this thing. One thing to be remembered, that whenever we divide the temperature in any of this section, like any chart we are making, so maintain symmetry. For example, 0 degree, 5 degree, 10 degree, 15 degree, 20 degree, 25 degree, and 30 degree. The difference between these numbers is 5. You can't make like 0 degree, 7 degree, then 10 degree, then 13 degree, and then so take a number with a uniform difference. Okay, so in troposphere the surface temperature is 25 to 30 degree. Let us take 25 degrees Celsius. Okay, this is degree Celsius. Okay, so if we move from lower troposphere to higher troposphere, temperature decrease. For example, this is 25 degrees Celsius. As we are moving in height, as we are moving away in the height, the temperature range is decreasing. Okay, here it's get constant. This is known as tropopause. Okay, when we come to stratosphere, within stratosphere temperature start increasing as we move in height, in latitude, in height the temperature starts increasing. Okay, this is the range. Then again constant. Again in mesosphere temperature starts decreasing. So decrease, it means it move towards 0 degree Celsius. Okay, so here it is moving. Okay, one thing to be remember, that mesosphere, the temperature is lowest in mesosphere in any of the ranges. For example, troposphere, stratosphere, mesosphere, ionosphere. In above all the ranges, if they ask that which layer has lowest temperature, then it is mesosphere, which we seeing in this diagram also. Okay, again in thermosphere temperature starts increasing. Okay, this is the range of temperature. Okay, it is increases, and in outer sphere temperature is high. Okay, this is the temperature line. Let us understand why. Okay, what are the reasons in relevance and temperature section? Why and relevance of it? Why the temperature decreases in troposphere as we move in height, and what is the relevance of it? Okay, so why temperature decreases with height? Okay, there are two or three reasons, I would say. The first reason is adiabatic cooling. Okay, adiabatic cooling, also known as normal lapse rate. Okay, what it mean? Adiabatic cooling and normal lapse rate. For example, this is the earth surface. Okay, earth surface which is getting very intensely heated. Okay, the heat has a property to transfer from warm body to cooler body. The earth is get intensely heated up, therefore it is a hotter body. Now the atmosphere or the range of atmosphere above the earth's surface, like this range, is cooler body. Since it is a cooler body, therefore heat is transferred from in this way, from hotter body to cooler body. Okay, when the heat is transferred, this here the low pressure condition has been formed. Okay, here the low pressure condition is formed. This low pressure condition push the convective currents towards upper side. Okay, this is moving. Now this air contains certain particles. These particles collide with each other. Now whenever the particles collide with each other, they create a friction within themselves. Now this friction is responsible for emitting energy. Whenever the energy is emitted outside, the energy released, it lead to decline in the temperature. Okay, energy is going outside, leading to temperature decline. Okay, whenever the earth convective currents move upside, particles collide with each other, friction creates energy imbalance, energy release. This energy release is responsible for temperature decreases. This is known as adiabatic cooling or normal lapse rate. Okay, we will study this thing in fundamentals. So this is the first reason why temperature decreases with height. Let us talk about the second reason, availability of gases. Now these gases are also the greenhouse gases, and we know that greenhouse gases is responsible for temperature, or we can say that greenhouse gases are responsible for heat heat capturing or accumulation. For example, this is the earth surface. Now this is the earth surface. Whenever earth is getting heated up intensely, it leads to transfer of energy or transfer of heat from the earth. This phenomena is known as albedo. Now whenever the energy is transferred from the heat, it it get accumulated or it get trapped by greenhouse gases. Now these greenhouse gases are responsible for trapping the heat, and since they are trapping the heat, therefore the temperature this side will higher. And as we move from earth surface, for example, this is the earth surface, this is the lower layer, this is the upper layer. Okay, here the greenhouse gases are in higher density. Okay, so here the trapping of heat is higher. As we move upwards from earth's surface to higher latitude, the greenhouse gases concentration decreases. As the greenhouse gases concentration decreases, therefore their capability to accumulate heat also decreases. Since their capability to accumulate heat also decreases, this is responsible for decline in temperature as we move upwards. Okay, this is the reason, the second reason for decreasing in temperature as we move upwards in troposphere. Okay, so we have done that. This is the second reason. And similarly, the third reason is presence of water vapor. Water vapor is also a abundant or important greenhouse gas, since the availability of water vapor is responsible for accumulation of heat, and the same phenomena that applies on greenhouse gases applies on water vapor. As we move upwards, this is the earth's surface, as we move upwards from the earth towards the higher latitude, the concentration of water vapor decreases. Since the concentration of water vapor decreases, therefore its capability to accumulate heat also decreases. Since its capability to accumulate heat also decreases, as we move upwards, the temperature in troposphere decreases. Okay, so this is the phenomena that why that temperature is decreasing as we move in upwards. There are three reasons we have discussed. One is adiabatic cooling. Okay, the second is GHG concentration, greenhouse gases concentration, and third reason is water vapor. Okay, this is the three reasons why temperature decreases as we move up in height in troposphere. Let us talk about the relevance of troposphere. Troposphere is very much important layer in the atmosphere. Why? This layer is contain water vapor. Water vapor is responsible for cloud formation. Cloud formation. Okay, this cloud formation is responsible for multiple things like precipitation. Precipitation, it means rainfall. This is cloud formation is responsible for precipitation, rainfall. It is responsible for cyclone formation. Cyclone formation. Okay, so this will also impact the heat balance on the earth albedo. However, that will be studied in environment classes. So this is the cloud formation responsible for rainfall and cyclones. Second thing, what is the relevance of troposphere? So it contains GHG. What is GHG? GHG is greenhouse gases. Greenhouse gases is responsible for global warming. Greenhouse gases are responsible for global warming. This global warming, what is the phenomena of global warming? Is that Earth, the average temperature of the Earth is increasing. Okay, this is known as global warming. So the impact of global warming is highest in troposphere. Why? Because the GHG is accumulated in troposphere. Okay, that's third relevance is presence of water vapor. Again, water vapor is a global have a global warming potential. Therefore, it is causing global warming. The second thing is water vapor is responsible for cloud formation. Water vapor is again responsible for climatic disturbances like cyclone, thunderstorms. Therefore, what is the relevance? Cloud formation, global warming, cloud formation, thunder, okay, climatic disturbances. Climatic disturbance. So this is the relevance of troposphere. All this phenomena is visible in troposphere. Okay, cyclone, everything from El Nino to La Nina. This all phenomena will happen in troposphere. Okay, so this is the most relevant range of atmosphere on the Earth's surface. Now let us talk about. We have completed troposphere. Okay, Now let us talk about stratosphere. Stratosphere. Again, we have to study stratosphere in that three parameters. The first is composition, the second is range, the third is temperature plus relevance. Okay, these three parameter we have to study the stratosphere. Let us talk about composition. For example, this is the stratosphere. Okay, this is the range is stratosphere from 13 kilometer of troposphere to 50 kilometer. Stratosphere, remember that divided into two parts. This is A, this is B. Now, what is this line? This line is O3, ozone layer. Stratosphere contain ozone layer. This ozone layer is responsible for absorbing harmful ultraviolet rays, UVC. There are three rays: UVA, UVB, UVC. UVA and UVB, this is UVA. Okay, this is UVB. This is UVA, this is UVB, and this is UVC. UVA directly penetrate towards the earth's surface. UVB partially absorb. Okay, partially absorbed by ozone layer. UVC is totally absorbed by ozone layer. Okay, they have different type of frequency, wavelength, and impact that we'll study in environment section. Okay, so ozone layer is present in stratosphere, which is responsible for absorption of harmful ultraviolet rays. Okay, so we have studied about the composition of stratosphere. It doesn't contain gases, however there are small amount but not relevant. Water vapor and other dust particles is absent in stratosphere, only present ozone layer. Okay, now let us talk about the range we have discussed, 13 kilometer to 50 kilometer. This is the range of stratosphere. Okay, let us talk about temperature and relevance. So we know that temperature from the first slide, we know, like if we move upwards in stratosphere, temperature increases. This is the increment line. Okay, this is the increment line. This is 25 degrees Celsius. In troposphere we have reached around 5 to 10 degrees Celsius, and then again it started increasing. So we have to understand that why the temperature is increasing in stratosphere is increasing. Okay, reason, first reason is absorption. Absorption by O3. Harmful ultraviolet rays, or we can say that sun UV rays, has been absorbed by ozone layer. Since it is absorbing the sun insolation heating, therefore the temperature increases in this area. The second reason is absence of adiabatic cooling. We have understood that what is adiabatic cooling. There is absence of adiabatic cooling in the stratosphere. Okay, therefore the temperature increases, not decreases with height. The third is absence of GHG, harmful, or we can say that the simply greenhouse gases plus water vapor. So absence of greenhouse gases and water vapor, which are responsible for accumulation of heat, this is also absent in the stratosphere, therefore temperature increases. The last point for the relevance section is that what is the relevance. The first thing is that jet planes or any plane operate in stratosphere. Why they are operate in stratosphere? Because stratosphere doesn't contain winds, doesn't contain horizontal winds, therefore the turbulence in the planes is less in stratosphere, therefore they operate in stratosphere. Okay, there are more turbulence in troposphere. Why? We have seen that there are convective currents are there. Therefore, when the plane is moving in this way and convective currents are moving in this way, there are more turbulence in the stratosphere, in troposphere. Okay. Therefore, the vertical movement of wind is absent in stratosphere. Therefore, jet planes operate in this. There are stratospheric clouds. Stratospheric clouds also been formed in stratosphere, which are responsible for O3 depletion. Okay. O3 depletion, what did it mean? The concentration of ozone layer, the concentration of ozone in the stratosphere is decreasing, which is known as, that is known as ozone O3 depletion or ozone depletion. Okay. This phenomena is because of presence of stratospheric clouds, and these stratospheric clouds contain pollutants, CH3, chlorofluorocarbons. Okay. CFH3. Okay, chlorofluorocarbons. These stratospheric clouds contain CH3, which are responsible for ozone layer depletion. Okay, so we have completed the two important layers of atmosphere. Now we have come to mesosphere. Okay, let us talk about the mesosphere. Again, we have to study this in framework, like what is the range. We have studied the range of mesosphere is 85 kilometer, up to 85 kilometer. What is the composition? So what is the composition of mesosphere? It contain, mesosphere contain particles. Okay, particles. So these particles, for example, these are the small particles are present in mesosphere. Whenever there is a meteor come to the earth surface, it has to pass from this layer of particles, the layer of these particles. These particles are responsible for creating friction in this meteor. For example, when meteor come in this range, the friction occurs. This friction is responsible for burning. Okay, this friction is responsible for creating burning or flames. Therefore, this meteor, when comes to this mesosphere layer, it got burn out. Okay, burning. Okay, whenever this get burning, it will not impact the earth. Okay, many of the meteors which come on the earth surface get ended in mesosphere only because of these particles. So we have completed mesosphere also and its relevance also. The last thing which is remaining is that why the temperature starts decreasing. We have seen in our diagram that temperature start decreasing in mesosphere and reach to lowest point in mesosphere. So what is the reason for decrease in the temperature in mesosphere? Okay, what is the reason? Simply the reason is that presence of adiabatic cooling or normal lapse rate. Why the normal lapse rate and adiabatic cooling is present? For example, this is the range. This is stratosphere. Okay, within stratosphere, temperature increases. So this range, this line, forming a stratopause. Stratopause. This stratopause is have higher temperature. Since there is a higher temperature, when we move towards upside, towards in mesosphere, towards more height, adiabatic cooling is started. This adiabatic cooling is responsible for decrease in the temperature. This is the first reason. Second thing, we know that there are particles in mesosphere. For example, these are the particles. This is the small particles are there in uh, mesosphere. Okay, whenever sun rays are come, this is the sun. When the sun rays are come and strike on this particle responsible for reflection of the sun rays. This is the reflection of sun rays. Okay, this reflection of sun rays, what is the relevance of reflection? Reflection means they are not accumulating the heat, they are transferring the heat. Since they are transferring the heat, temperature will not increase, temperature will decrease because reflection is there. For example, light when strike on a reflecting path, it will strike and get away from that. It will not get absorbed. Since it will not get absorbed, what will happen? Temperature decreases. This is the reason that mesosphere, why the temperature decreases in mesosphere. There are two reasons. First is presence of adiabatic cooling, and second is presence of particles. These particles are responsible for creating reflection. This reflection is responsible for not absorption but reflection of sun rays. And sun rays, if we reflected, therefore temperature decreases. So let us come to the final layer, which is ionosphere or thermosphere. Okay, again look into it. Temperature decreases, again increases. Okay, temperature is increasing as we move upwards in thermosphere. So again in thermosphere, again in thermosphere, we have to study first is range. What is the range of thermosphere? The range is, we know, it is around 600 kilometer. Okay, more important is composition. What is the composition of thermosphere? We know that thermosphere is also known as I- ionosphere. So why it is known as ionosphere? Why thermosphere is known as ionosphere? Because it contain ions. What are ions? Ions are nothing but charged particles. Charged particles. Now we have to understand that why ions or charged particles accumulate in only thermosphere or ionosphere, not in the lower layer. This is the earth. This is the geoid shape. This earth, we know that earth act as a magnet. So this is the north pole or south pole, and this is the, let us consider it's the north pole and this is the south pole. Whenever the sun, this is the sun is responsible for everything on the earth in the atmosphere. Okay, so whenever the sun releases its sun rays, it lead to transfer of electromagnetic waves. Electromagnetic waves contain charged particles. These charged particles, for example proton and electron, get accumulated in north pole and south pole. Every time whenever we see a magnet, we know that charged particle will attracted at the north and the south pole, not at the center. It is accumulated in the north pole and the south pole. Therefore, these charged particles will accumulate at north and south pole. Now, why ionosphere? Because range. For example, the north pole of the of Earth is this. Okay, if the charged particle come at lower level, it will come to the surface. Okay, because charged particle get attracted to, for example, this is the electron and this is the proton. Earth's surface contain charged particles. If it come to lower level, it get attracted towards the earth surface. It will not get accumulated in the atmosphere. It will come to the earth's surface in the form of lightning. Okay, we have seen the lightning. So in the form of, therefore they get accumulated in ionosphere. Okay, so what they form by accumulation? They are responsible for creating lights. Now, what are the lights? There are two types of lights: aurora borealis and aurora australis. Aurora australis has been formed at south, and aurora borealis has been formed at north. These are the lights which has been formed because of accumulation of charged particles at the poles. So this is the composition and this is the relevance of thermosphere or ionosphere. Okay, so we have completed all the things. The last layer, which is exosphere, this is nothing but a outer atmosphere. It reaches up to 10,000 kilometer. I can write this 10,000 kilometer is the range of exosphere, or it may be higher, but it is not relevant for our examination. Simply they are going to ask that what is the structure of atmosphere. We have to make a diagram, we have to explain troposphere, stratosphere, mesosphere, ionosphere, that's all. On which parameter we can explain, this is the parameter, what is the range, what is the composition, what is the relevance, okay, and what is the temperature. If you want to explain the why the temperature is increasing or decreasing, that's good. Otherwise it is not recommended to explain why the temperature is increasing or decreasing. You simply mention that in troposphere temperature is decreasing, in stratosphere temperature is increasing, in mesosphere coolest layer and temperature is decreasing, and in thermosphere temperature is increasing. Simply you can write that. Relevance, I have told you, relevance you have to mention. And in this parameter, if you write uh, in a broad question, I think 15 marker, you can complete all the things, and you can achieve a good marks, I think. So lastly, if you want to give a conclusion, then you can write that write about global warming and why the atmospheric structure is changing and what is the impact. Simply you can write that atmospheric structure atmospheric structure is not changing, but the composition of the atmospheric structure is changing and the relevance is getting important. Why? Because of global warming, and global warming is impacting humans, ecology, largely earth. And this is responsible for what? Threatening life. Now life is not only humans, every life is get threatened because of global warming, and global warming is happening in atmospheric structure, which is which layer? Thermosphere. Okay, you can conclude through this. So thank you. So that's all from my side. Thank you.